Alright, silly people, here's the situation. Griffiths is just going to run us through a process of proving the Schwartz inequality. Um, that is just that uh, if you take the inner product of two vectors and then square the result, um, that's going to give you a number that is less than if you were to just take the magnitude of both and multiply them by each other, right? So the way that Griffiths is going to have us do this is he defined this vector gamma here, which is beta minus the inner product of alpha with beta divided by the magnitude of beta or of alpha um, times alpha, um, and the fact that the inner product of any vector is greater than or equal to zero with it, any inner product of it with itself. Yeah, greater than or equal to zero. So there's beta. Let's just then take the inner product of it with itself. So that's going to look like the beta bra minus this guy, alpha with beta divided by bra alpha ket alpha times ket alpha. But actually, this is going to be bra alpha. That's the complex conjugate of gamma. And then this is just gamma here. Uh, so we have to do the multiplication of these. So the beta bra is going to get multiplied by the beta ket. So we have the inner product of beta with beta. Um, the beta bra is also going to be multiplied by this term, so we're going to have a couple of cross terms. Both of them are going to be proportional to um, the inner product of alpha with beta divided by the inner product of alpha with alpha. So like I just said, there's going to be an inner product of beta with alpha term, and also an inner product of alpha with beta, which is the complex conjugate of the other term, but yeah. And then you're also going to have this term squaring this term, so plus the inner product of alpha with beta divided by the inner product of alpha with alpha, all squared, times the inner product of alpha with alpha. Right. Okay. Um, and the left-hand side, since it's just the inner product of gamma with itself, turns into less than or equal to 0 is how I'm going to do it. Okay. Um, so what I'm going to do now is I'm going to multiply both sides of the equation by the inner product of alpha with itself. So 0 is still 0. We have now the inner product of beta with beta times the inner product of alpha with alpha, right? Um, the when we multiply the inner product of alpha with alpha, the one on the bottom here will cancel. So we just have alpha beta times beta alpha plus alpha beta here in these parentheses. And then we're going to have an alpha beta squared term here divided by alpha with alpha squared times alpha with alpha now squared because we multiplied both sides by, yeah, that inner product. So this term on the bottom will cancel out this term on top here. And we will carry out the integration or carry out the multiplication of the middle term. So we're going to have alpha with beta times beta with alpha minus alpha beta squared plus alpha with beta squared. So this term will actually cancel out this term. And then we can move this to the other side and notice that it is just the definition of the mod squared of alpha with beta. And then the only term left on the left hand side, or on the right hand side, is this guy. So that's the Schwarz inequality. So cool stuff.